Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 5.2.1, problems 29 through 33. The first problem asks us to find the probability of each one of these events, and then to record them as both a fraction and as a percent. So let's take a look at it. A, drawing a diamond from a standard deck of cards. Now remember, a standard deck of cards has a total of 52 cards, and there are basically four sets, or four suits. That's what we're looking for, four suits. Those would be hearts, diamonds, clubs, and spades. And so the diamond would be 1/4 of the cards, because that would be one out of the four suits are diamonds. And if you just went and counted all the cards, 13 of those cards would be diamonds, 13 would be clubs, 13 would be hearts, 13 would be spades, and that's 13 out of the 52. So if you just did it by cards, it would be 13 out of 52. If you simplify it, 1/4 is the simplified version of that, which happens to coincide with the suits, and 1/4 is equivalent to 25%. All right, rolling a number less than 5 on a standard number cube. All right, so remember, the standard number cube, otherwise known as dice, would have either 1, a 2, a 3, a 4, a 5, or a 6. And so if you were going to roll a number less than 5, then that would be the 4, the 3, the 2, and the 1, which represents 4 out of the 6 possible outcomes you can get when you roll a die. 4 out of 6 would be the fraction of the probability, but then you simplify that down to 2/3, which is the same as 66 2/3%. And then drawing a marble, a blue marble, from a bag of 18 marbles, 3 of which are blue. So remember, in the denominator of our probabilities, that's the total. We have a total of 18 marbles in the bag, 3 of which are blue, so those would be our desired outcomes that would go in the numerator. So 3 out of 18 is the same as 1 out of 6, and 1 out of 6 is equivalent to 16 2/3%. Okay, so more probability. Imagine a standard deck of cards with all the aces and twos removed. Okay, so remember, there are 52 cards in the deck, and there are a total of 4 aces. So if you take away all the aces, that means there would only be 48 in there. And then if you took away all the twos, there are 4 twos in there. That would leave you with 44. So now our total, after the aces and twos have been removed, is 44. So what's the probability of getting a heart now? All right, so we've established here that there would be 44 cards in there. Now let's take a look at the situation. We've got hearts, you've got diamonds, you've got clubs, and you've got spades. And remember, there are 13 of each one of them, and that's the 52 cards in the deck. But if you took out an ace and a 2 from each one of those suits, that would be removing 2 from each one of them. So now you've got only 11 hearts, 11 diamonds, 11 clubs, and 11 spades. So there you go. Your 11 hearts out of the total of 44, 11 out of 44 is the same as 1/4. The black cards would be the clubs and the spades, so that would be 11 and 11 makes 22, so that would be half the cards are black. And then the face cards would be the jack, the queen, the kings, and so there's 3 of those in each one of those suits, so that would be a total of 3 times 4 is 12. So you got 12 face cards out of 44, which is 3 out of 11 once you simplify that probability. And then it says, how is the face card different with this deck from the probability of the deck without missing any cards? Well, the difference is you got 12 face cards out of 52 total cards in a normal deck. So that would be the same as 3 out of 13 as opposed to 3 out of 11. So which is the greater probability? You've got a greater probability of pulling out a face card after you've removed a couple of cards that are not face cards. So this lowered the total. We didn't lower the total of face cards, so that means your percent is going to be a little bit higher. And so in a situation like this, it's probably better to convert these probabilities into percents, which I've rounded off here, so that you can see, that 3 over 11 is clearly greater than 3 over 13 once you see it as a percent. 27 is greater than 23. And then problem E, that is not a heart, so this would be like the complement. If the hearts were 11 out of 44, then the rest of them would be 33 out of 44. So 1/4 versus 3/4. All right, so what do we have here? The Kennedy High School cross-country team ran the following distances in the recent practices. Find the mean and the median of the team's distances. Okay, so we could use a spreadsheet to figure out the mean and the median, but we only have 1, 2, 3, 4, 5, 6, 7 of these. So let's start by finding the median. The median is what you get when you put all of these in order from least to greatest, and you find the number that's in the middle. So I'm going to take the lowest one, which is 2.5. And the next one would be the 3. Then you got a 3.25. Then you've got a 3.5. Then you've got 2 4s. And you've got a 6. So we've got which one of these in the middle, which it looks like the 4th one in. If you've got a total of 7 numbers, half of 7 is 3.5, so round that up to 4, and the one that's in the middle is going to be your 3.5, so that is your median. Now, now for finding the mean, this is a little bit more challenging, but it's not too bad when you've only got 7 numbers. You just got to add them all together and divide by 7. So I'm going to go ahead and stack these guys up and make sure that we've got digits in each one of those decimal places. 3.50, and then this is 4.00, 4.00, and 6.00. So what do we have? 50. This says money. 50 cents. That's $1, $1.25. So I'm going to put the 25 cents there and the dollar here. Then you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 and 8 makes 20, so it's 26, 25. So we got to take 26, 25, and divide it by 7. And I'm going to go ahead and use my trusty calculator for the rest of it. We can go ahead and do the division. Wouldn't be too much trouble, but why do it that way when you can be efficient with your time and use a calculator? 3.75. So that's going to be your mean right there. Okay, so mean and median are pretty close to each other, which suggests that you don't really have much of an outlier in the data. It's not like one day the cross-country team ran 25 miles. That would really skew the mean, while it wouldn't change the median too much, right? If you added one more day on here and had that 25 miles, now your median is going to be 3.75 because it would include the average of those two numbers. So the median is great when you've got an outlier, but if you don't have an outlier, you can really use either one. And so both of those are really close to a mean, or to the mean. All right, find the area of each figure below. This is a parallelogram, so the area is going to be defined by base times height. This is a triangle, so the area is going to be defined by taking 1/2 of the base times the height. And the base and the height are the two measures that are perpendicular to each other. So any one of these sides of this parallelogram could be the base. Because we've got this distance right here measured perpendicular to this side right here, we're going to call this the base, and this will be the height. So base times height is 27 times 17. Go ahead and prove that. 27 times 17 is equal to 459, and that would be square inches because we're counting the total number of squares that would fill up this entire space. The triangle, the base and height, same thing. You could literally have any one of these sides could be the base. The height has to be a perpendicular line from the base to the highest point of the triangle. So this is going to be your height, and this is going to be your base. So we're going to take 20.75 multiplied times 9, and then once again we multiply that answer times 1/2. So I'll just go ahead and do that. I'll take, come on, calculator, come on. So we'll just take 20.75 times 9 times 0.5, which is 1/2, and you get 93, and I rounded it up to 0.8, but you could have said 93.375. Don't know why I rounded that up, but I did. Either way, both answers are fine. All right, and now we're going to have to use the order of operations, which is PEMDAS. Or if you choose to circle your terms, you can do that as well. So I'm going to actually solve problem A by circling the terms, and I'll solve problem B by using the order of operations PEMDAS, and you'll see that either way the answers can be right. So here, circling the terms, here's one term, right? This complicated mess being added to this less complicated mess, and then subtracting away that. So let's complete what's inside here first, and then go from left to right with the addition and subtraction. So this is going to be 3 times 4 is 12, plus 16 minus 5. So you get 12. 28 minus 5 is indeed 23. Here, I'm going to go ahead and rewrite this because this is one of the downsides of using order of operations is you sometimes take a little bit more space while solving the problems. So I'm going to kind of funnel my way down here. First thing, we have no parentheses, but we do have an exponent. So I'm going to do that, and I'm going to rewrite everything else. Now I've taken care of the exponent. Now we do multiplication division. So here's multiplication here. Here's multiplication here. And we don't have any more multiplication. So what I just did basically is by following these order of operations and taking care of this section first, I basically am just doing the same thing as circling the terms. But I was doing it with the entire expression in mind instead of just 3 little mini expressions. That's why CPM and a lot of students like doing it this way better, because you can do some mental math in here and boom, 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 there you go, you got your answer. Whereas this, a little bit more complicated. So let's go ahead and finish this. I think I'm going to go from left to right here. 28 minus 24 is 4, and 4 plus 4 is 8, and 8 minus 6 gives us our answer of 2. Okay. So if anybody wants me to work on C or D, I would be happy to do that. Just let me know, and I will work those out for you. Otherwise, we're going to move on to our next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood.